In this video, I will explain you what will happen when the lens is immersed in a liquid. What will happen to its focal length and power. Okay. Now we have the equation for power, that is nothing but 1 by focal length, and the value mu2 by mu1. Mu2 is nothing but the refractive index of the material of which the lens is made up of. Mu1 is nothing but the refractive index of the space where the lens is placed. Okay, so mu2 divided by mu1 minus 1 into 1 by r1 minus 1 by r2. So r1 is nothing but radius of surface 1, okay, radius of this, and r2 is nothing but radius of surface 2. So anyway, these are geometrical properties, r1 and r2. So lens, its geometrical shape is not changing. So I can say that when the lens is being immersed in a liquid, its radius, this one and also this one, doesn't change. So r2 and r1 is the same thing. Okay, so this part of the equation would be same. What is changing is this part, and out of that 1 doesn't change, and even mu2 is also not changed. Mu2 is nothing but refractive index of the material of which the lens is made up of. What is changing? The refractive index of the surrounding is changing. Now this is, okay, I can compare this equation as x minus 1. Now if x is 5, then 5 minus 1 is 4. Now from 5, if x is decreased to next value, that is 4, then this would be 4 minus 1, 3. Now if x is increased to 6, then that would be 6 minus 1, 5. So similarly, when this value increases, then the whole value increases. Like when x increases, x becomes 6, the whole value 6 minus 1, 5, that increases. Now 5 multiplied by this, the whole value would increase. Okay, now out of this, this is the same. That doesn't change. What is changing is mu1. Now when the mu1 increases, so when mu1 increases, so mu1 increases is the case what I am going to explain here, that for refractive index of, okay, when the lens is kept in air, the refractive index is approximately 1 or 1 point something. Okay, now the same lens, when it is kept inside water, then refractive index of water or the liquid become approximately 1.3. Now when, okay, when lens is kept in water, what will happen? Mu1 increases. In air, mu1 was less, around 1, but in water that is 1.3. So this value would increase. Now when denominator increases, the whole value would decrease. When this decreases, as I have told you, from 5 when it become 4, then 4 minus 1, this will become 3. So this increases, mu1 increases, the whole value decreases. When the whole value decreases, this whole value decreases. Now the number by which 1 by r1 minus 1 by r2 to be multiplied, that number decreases. So when this decreases, for example, this equation can be multiplied as, can be compared as my. Now when m is 2, then that is 2y. Now when m is 3, then that is 3y. Now when m decreases to 1.5, then this would be 1.5y. So similarly, this value is being multiplied by this number. When this decreases, the whole value, this function decreases. Now when this decreases, I can say, so power decreases. So mu1 increases, the whole value decreases. Now this whole value decreases. Now the total function decreases, power decreases. Now power decreases means here in this case focal length has increased, because power is equal to 1 by focal length. So I can say that when a lens is, bringing all the parallel lines to one point, that is focus, if the focal length is 5 cm in air, then the same lens, when it is kept inside a liquid, then the focal length would become 7 or above, or any value above 5. Now this need more distance to bring all the lines to one point, or now the bending power of the lens would decreases when it is kept in a medium like this. So when refractive index, when mu1 increases, okay, this would happen when it is kept inside a liquid and the liquid is having a refractive index more than air. Now if the refractive index is less than air, then the opposite, but that is very rare chance, and I can say that practically it is not possible. So whenever lens is kept inside liquid, power decreases and focal length of the lens increases. Okay, thank you.